Okay, in this video, I'm going to show you guys how to do the noble gas configuration for these. So eventually what I will do is I will do the noble gas configuration for arsenic. And arsenic is what we're going to look at first. So all the noble gas configuration is just a way to abbreviate this so we don't have to write out a good chunk of this every single time we go to write out the electron configuration. We're actually going to cut out all of the extra stuff and only leave behind the important stuff. So it's all of the information that tells us about the highest energy orbital and the outermost electrons. So to figure out first off which noble gas we are going to use, if we look at any periodic table for the most part, this will work for, as long as we're not dealing with the F block. So again, we're just going to stick with arsenic. You're going to find your element. You're going to go up a row. So arsenic is in group 4 or in row 4. So we're going to be looking at row 3, and then we're going to go all the way over to our noble gases. Remember, the noble gases is this 8th column here. So the element that we're going to stick with is argon. So let's move this out of the way. So for arsenic, what we'll do is we write argon because argon's electron configuration, if we were to write all of this out, it would be 1s2, 2s2, 2p6, 3s2, 3p6. So there is argons. The easiest way to figure out what our last one is looking at your colored periodic table. When we look at arsenic, it is argon, it is in the 3rd row, and it is in the P6 column, so it ends with 3p6. So then what we have to do is we have to figure out what's the next one to write after that. So when we look at it, when we look at our diagonal rule chart, we find 3p6 here. So our next one is going to be the 4s and then the 3d and so on and so forth. So at least 4s. Now, when we look at the difference between arsenic and argon, arsenic's atomic number is 33. Argon's is 18. So 33 and 18. So the difference between those is 15. So we need to add on 15 extra electrons onto this. So as we go through and write this, so the 4s can only hold 2. Our next one we look at our diagonal rule chart past the 4s would be the 3d. So that will hold 10. And so we've only used 12 so far, so we've got 3 left to write. So when we look at our diagonal rule again, it goes to 4p and then 3. So if we look at arsenic's completely written out to double check ourselves, we do notice that we have the end part written correctly, and we've essentially taken all of this extra stuff out front, which is what argon's electron configuration is, and then just shortened it and just called it AR.